Hello students, in the GATE Computer Science series, we were discussing the concept of layering in the subject named Computer Networks. So in this video, we will be discussing about the network architecture. So what do you mean by network architecture? Then the two types of network architecture that we have, which is the OSI model and the TCP IP model. So what is a network architecture actually? So why do you need a network? The main aim of a network is to transmit data between two devices like sending and receiving files, etc. For that purpose, the network we create, it must be cost effective, fair, robust, then it should have a good performance. So in order to achieve that, we need to customize a new proper network, right? Designing such a network that meets these criteria, it's not a simple task actually, it's very difficult. But in order to deal with this complexity, the existing network designers, what they have done is they have developed some general blueprints. With the help of these blueprints, we can design or customize a network for our organization without any hassle. So those two main architectures are the OSI architecture and the TCP IP architecture. So initially, why do we need layering actually? Just like I mentioned, right, in the OSI model we have so many layers like the physical layer, data link layer, network layer, etc. The main aim of layering is to provide a modular approach to networking. So it provides abstraction to hide complexity. Maybe abstraction normally leads to layering, right? For example, that there are a few layers. For example, consider a manufacturing company, like it is manufacturing and selling soaps, for example. In such a case, in the you might have seen the automated machineries, like, right, one module it will be there, it will be like a molding the soaps into their required shape, and in the next layer it will just be packaging the appropriate it will be providing the appropriate package to that soap, and in the next module the package will be sealed, and in the next module all the soaps will be packed in a box, like in a cotton box, in order to sell it to the retail shops. So each module does its own function actually. Each module, it won't interfere with the other module's function. So this layering concept, it is flexible, right? Each one won't interfere. Each person will do their own duties. For example, consider if we have 6 subjects in this semester actually, which may be OS, DBMS, English, then engineering, maths, and then network, etc. So in this case, so there are 7. Consider these are each separate layers. So in your mark sheet, all the subjects will be the results of all the subjects will be printed as a single mark sheet, like semester wise performance. But for each subject, a different faculty will be allotted to you. So the OS faculty, she will handle that subject. Likewise, in the English teacher will handle this subject, then maths teacher will handle the subject separately. There won't be any communication among these teachers, and there won't be any interface. So there won't be any communication among these two faculties, or any link between these two layers, but each layer will perform its own function. Like each teacher will handle their own subject separately, but the result will be printed together as a single one. So this will be a performance of your semester. Likewise, in the layering approach in network, so each layer it will have its own functions. So other layers, it won't interfere with the next layer's function, but they will be doing their own function. But there will be a proper communication protocol in order to maintain communication among those two layers. So those two layers can communicate among them, like the OS handling faculty may communicate with the DBMS faculty, but she won't interfere in the DBMS subject actually. There may be communication, but it won't interfere with the other layers functions actually. This is the layering concept actually. Then talking about protocols, we know protocols, right? Protocol is just an agreement between two nodes, like the set of rules. Like if two nodes want to communicate, it should follow a communication protocol or network protocol, like how the data should get transmitted, what are the set of rules that it should satisfy, that it deals with it, protocol. So in each protocol object has 2 different interfaces, like which is the service interface and the peer-to-peer interface. So the main aim of the service interface is to enable communication among objects within the same host. For example, your PC may have so many processes running inside it. For example, your printer may be running its own separate process and each tab in your browser, it will be running a separate process. So in order to ensure communication among these objects, the protocol which it follows is that the service interface deals with it and the peer-to-peer interface, it deals with communication among two hosts, like between the device A and device B. What is the form of message that should be communicated? Like it deals with that thing to implement the communication between two hosts actually. Next comes the concept of encapsulation. Encapsulation means data hiding or abstraction maybe. The main aim of encapsulation is to hide something so that others can't see it. For example, if you are sending a job application, like hard copy of a job application to any company, for example, you may be filling your application form, taking a printout of it, and then what will you do is you will just wrap it with an envelope. This envelope will contain your from address and the to address, like the company's address, and this will be sent to this courier will be delivered to the office actually, and the office people, what they will do, the HR team they will unwrap the envelope and they will view your application and check whether you are eligible for this job. So this wrapping the additional details, like in the form of an envelope or in the form of header, or in network case they will be adding headers. In each OSI layer, like each frame that we design using the data link layer, it will have its own header, like the source and destination details of source MAC address and destination MAC address, it will be recorded in the header part only. So this process of adding trailer or header to the data from the upper layer is called encapsulation. So the final data will have two parts. One is the data part, another one is the header part. Next we can see about the OSI architecture. International Standards Organization, it is the multinational body which is dedicated to worldwide agreement on international standards actually. So this OSI model is developed by them. So OSI means Open Systems Interconnection. So this is a model for understanding and designing a network architecture which is flexible, robust and interoperable. This OSI architecture is built upon 7 layers which are data link, physical, network, transport, session, presentation and application. And just like I mentioned earlier, the main aim of layering is that during transmission of data from one device to other device, there are so many functions involved in it. To easily manage these functions, the functions, the properties or the duties that are related to one particular layer, it will be confined into distinct groups. These becomes the layers actually. So these well-defined interface between these layers and the layer functionalities provide modularity to the network. In OSI layer, when one node A decides to send data to the node B, from the application layer it will receive the data, then it will pass down all the layers. So while passing, in the session transport layer, a new header will be added. Like this header will include the source and destination details. In addition, the data will be separated into segments. Each segment will have its own header, and till here the file will be traveling as it is, but in the transport layer it will be file will be split into separate segments. Like each transport layer, network layer, data link layer, each will have its own MTU. Like MTU means maximum transmission unit. So transport layer will have a maximum limit of how many segments it can handle. So if its MTU is 500 segments, so this layer data will be split into 500 segments and each segment will be sent separately. And in the data link layer, in the network layer, it will have its own MTU, like MTU of 500 packets. So in each segment, if a segment is having data which is more than 500 packets, then that segment will be split into 2 or many fields, and each will be separated actually. Each 500 packets will be sent as a separate one, and next like a division takes place. Likewise, when data moves from the network layer to data link layer, it will be split into frames. Based on the number of frames, like the MTU size, it holds like, if it holds like 20 frames, it will be split into 20 frames separately. And in the last, if it's only 2 bits remaining, and the remaining bits will be they will be padding the remaining bits with zeros or something in order to fill the size. And the data reaches from the source node host A, it passes all the way from the application presentation and it reaches the final physical layer, and from the physical layer it will be passed as analog signal and finally it reaches the destination device physical layer, and it goes all the way to the application layer in order for node B to view the data actually. So while one more thing to note is that when the data gets transmitted, like when it passes all the way down, in transport layer a new header will be added which includes the extra details, and then source details and the destination details, and then to a network layer its header will contain the IP address of the source and destination. The data link layer, it will, in addition to this, it will contain a header which includes the source and destination MAC address, and the physical layer it will be passed as a digital data like bit stream. Then when it reaches the receiver, what happens here, it's like wrapping a gift here. Wrapping happens, and in the receiver part unwrapping happens, like unwrapping and viewing a gift or something. After it reaches the data link layer, it will unwrap the thing which was done in this layer, and it will be able to see the source and destination MAC address. And again in the data link layer, it can be in a position to unwrap the thing which was wrapped by this network layer, which is the source and destination IP address, and then it will act accordingly. And then in the transport layer, likewise unwrapping happens all the way up, and the final only the data part alone will reach the destination, and the host B can view the data alone. The host B, the receiver and the sender, they have no idea that these headers are added all the way, and the headers, additional headers were removed when it reaches the node A. They just know that they had transmitted the data and the receiver has received it. They will have no idea like this will be completely behind the scenes. This OSI architecture is followed for every single data or every single message that you send online. Then we can now see about the functions of the physical layer. The physical layer usually coordinates the functions required to transmit a bit stream over a physical medium. The physical layer is concerned with the following, like the physical characteristics of interfaces and media are defined, and also the type of transmission medium is defined. Then representation of bits. So in this, it defines the type of encoding which is used to convert the zeros and ones to signals, like digital to digital encoding takes place here, and only the signals which are electric or opticals can be transmitted through this medium, and each device has its own data rate. Each data that we send, data rate is what we discussed, right? The amount of bits that gets transmitted per second. Then synchronization takes place. The sender and the receiver device should be synchronized at the bit level, which means the clock of the sender and receiver should be synchronized, or else in the receiver side they may decode it as a wrong signal. And then line configuration, it defines the type of link, which the type of link may be point to point or multi-point. It depends on the network requirement. Then talking about topology, this topology actually defines how the devices are connected in order to make a network. Here we can either use the tree topology or bus topology. Bus topology is more common for a simple network, and for a larger network we use tree topology. And about the transmission mode, this transmission mode, it defines the direction of transmission. So this transmission mode can either be simplex or half duplex or full duplex. Next, the data link layer. This data link layer is responsible for node to node delivery. Node to node means neighbors, node to node delivery, and also to ensure error free data delivery to the upper layer. So when we talk about data link layer, the main things you just have to remember is it guarantees flow control and error control. The responsibilities of the data link layer include framing. the stream of bits from the network layer, it will be divided into manageable data units called frames. And talking about physical addressing, the address of the sender and receiver will be placed in the header attached with the frame. So in this header, we will be having the source MAC and destination MAC. If the receiver node is outside the sender's network, then the receiver address is the address of the device which connects the sender's network to the next network. So if the nodes, if these are the nodes, if node A wants to send data to any other node in this network, it means its source MAC address should be the A's MAC address, but the destination MAC address should be its neighbor's MAC address, not the ultimate destination, since it belongs to different device. But the network layer should be used to transfer data to the devices which are in some other network. Talking about flow control, like flow control is just the speed at which the sender sends and the receiver receives the data. So this speed should be balanced. For example, if the sender is sending data at a speed of 10 frames per second, but the receiver can process only 5 frames per second, which means in 1 second it might have sent 10 frames, but it has processed only 5 frames. The remaining 5 frames will be in the queue. Then again in the next second it will send again the next 10, but again this will be in the queue, and this 5 would have been processed by now. So when time goes on, what it will happen is congestion takes place in the receiver end, and they will start dropping the frames and data loss occurs. In order to avoid this, like the speed at which sender sends and the speed at which the receiver receives the data, it should be balanced. Then talking about error control, the data received, it should be checked for errors through the trailer added to the end of the frames. We will be adding an extra bit, like just how we saw in the block coding scheme. Then error control mechanism, it should detect and retransmit the damaged or lost frames, and it also prevents duplication of frames. Then talking about access control, this data link layer protocol, this protocol will decide which device has access over the line at any given time. For example, since they have the bus topology, only one node can transmit data at a time. So accessing this bus is defined by this access control. Next, we have the network layer. The network layer is responsible for source to destination delivery of packets across multiple networks. The responsibilities of the network layer include logical addressing and routing. Just like how we said in the MAC address, in the data link layer, the source and destination MAC address should be known. MAC address is a 48-bit address actually. Likewise, in the network layer, we need the use of IP address. The IP address is the 32-bit field. So if you want to transfer data between multiple devices, we just have to know the source IP and destination IP. This details, it will be wrapped in the packet header. The header will contain the source and destination IP address. And routing is the main functionality done by the network layer. Routing the packet to the right destination is the task, is its main duty. It will maintain a routing table, and it will maintain a list of its neighbors, like how to reach to node B from node A, what are its neighbors, like those things will be handled by the network layer. Next, we will be talking about the transport layer. This transport layer is responsible for end-to-end delivery. So data link layer is for node to node delivery, which means neighbors. Transport layer is like end to end. End to end means the ultimate source to the ultimate destination. So in the transport layer, data will be divided into segments, and each segment will be sent separately to the next layers. And when reaching the destination, these segments, so each segment will have its own sequence number, and after reaching the destination, all the segments will be merged together as a single message with the help of the sequence number, so that ordering is maintained. So this thing, like dividing the data into segments and then reassembling them at the receiver end, is called segmentation and reassembly. Here we make use of the concept called service point addressing. Just like how I mentioned, the socket address is a combination of IP address plus port number. So this thing is called service point addressing. Actually, for example, if there are so many tabs in your browser, and in one tab you are accessing the Amazon server, which means your request to the Amazon server will be sent. So in the header part, it will have a combination of your IP address plus the port number. So this tab has its own port number actually. So the Amazon server will view your request, and when it responds, with the help of your IP address, the response will reach your laptop or PC, and you only using this port number, it will redirect the response to the corresponding tab. Actually, this tab will have a particular port number, the next tab will have some other port number. So this is the main purpose of a port number. There are so many port numbers reserved for specific purposes. The receiver resembles the segments in order to get the entire message. Port number is a 16-bit address, actually 16-bit number. Next, talking about connection control. Transport layer can be connection oriented or connectionless. Connectionless transport, it reads each segment as independent packets and delivers it to the transport layer as destination. But connection oriented service, what it does is it establishes a dedicated connection between the source and destination, and then with a proper handshake, and then it will start transmitting the data, and the receiver will send an acknowledgement that it has received, and after sending all the data, it will just send a request to terminate the session, and the connection will be closed. So this happens. Usually TCP is an example of a connection oriented. TCP means TCP is transmission control protocol. TCP is mainly reliable because every packet you send, it will be here we addressed a segment, right? Every segment you send, it would have reached the destination, and no data lost here. So it's ultimately reliable. But when you see the connectionless protocol, it is unreliable. So there's no guarantee that every data that you send, it will be received by the destination. There may be some packet loss due to bandwidth issues. For example, UDP, like user datagram protocol, follows this standard. So TCP is mainly used in situations like the TCP or the connection oriented protocol is used in situations when data loss is unacceptable. Like you just have to send every data without any loss. And connectionless protocol, and a good example of connectionless protocol would be like video call that we do. Like in some time when our network is slow or a signal is too weak, the video call, it normally it pauses, right? It will be in one frame itself, it won't be moving. So a packet loss would have happened at that time. So UDP is mainly used when such data loss is acceptable and there is no issue. In that case, you can use a UDP. And then talking about flow control, it is the same as the data link layer. Like the speed at which the sender sends the data, it should match the speed at which the receiver receives the data. Then error control is the same like in data link layer, but here error control is performed end to end, and the error correction is done through retransmission. If they detect an error, they will retransmit the bits which were in error. Then we'll discuss about session layer. So session layer is the network dialog controller. Actually, it establishes, maintains and synchronizes the interaction between communicating systems. The responsibilities of session layer include dialog control and synchronization. Session layer allows two systems to enter either in half duplex or full duplex. Session layer in the sense, for example, if you are accessing the net banking portal of your bank, for example Indian Bank, so for a few minutes if you are idle in the web page, it will throw an error, right? Your session is expired, login again, which means the server has automatically closed the session for security reasons. So session is like a proper connection, establishing a proper connection between the source and destination. And once the communication is over, the session will be closed. Again, if you want to communicate, a new session should be created in order to establish the communication. So again, the second concept we have here is synchronization. So synchronization is the process of adding checkpoints into a stream of data, so that if any crash occurs, you can handle it without, so that you just don't want to retransmit the entire data. For example, you have 500 bits of data to send, and you have sent 20 bits, and here the system has created a checkpoint. So checkpoint 1, after sending 50, next 50 bits, again checkpoint 2 it has set. Then again you are transmitting data. Now maybe if you have transmitted 10 bits, now here network failure happens and data loss, so the connection gets lost actually. So in such a situation, what happens is the data which was transmitted till the previous checkpoint, like right, the checkpoint 2, it will have been saved, and only the data which was transmitted after this checkpoint, it will be lost. So here 10 bits would have lost, and the remaining 70 bits it would remain the same. So in order to retransmit the data, like data loss has occurred, right, then the system crashed. You just want to retransmit the data. In such a case, these 70 bits don't have to be retransmitted, only the bits which were transmitted after the checkpoint, it should be transmitted. This is all about synchronization. Then talking about the presentation layer, this layer is mainly concerned with the syntax and semantics of the information exchange between the two systems. Like presentation is all about how we present the data, the format, all those things. Presentation layer has three responsibilities, which are translation, encryption, and compression. Translation means like each device may incorporate its own encoding scheme. Like one device may use this 4-bit, 5-bit encoding, one device may use 8-bit, 10-bit encoding. So encoding schemes may differ, but they just have to understand it. Like interoperability issues may occur. In order to resolve it, this presentation layer is used. Like this serves as a mediator. For example, if you are viewing a web page which is written in Arabic, the system will prompt you, like the browser will prompt you, this page is in Arabic, do you want to translate it to English? Like this thing is actually done by the presentation layer. The second function is encryption. For example, if you are dealing with any sensitive data, like just like the common people, they don't want to see it if you wish so, you just have to encrypt it for securing the privacy purposes. So the receiver can decrypt the data at the receiving end in order to view the original message. So these things also, this encryption will also be done by the presentation layer. Then talking about compression, compression is just like reducing the number of bits to be transmitted. For example, if you don't have the data, sufficient data or bandwidth to send such a huge file, you will just compress it to a zip folder, or just reduce the size. Like we have so many size reducing tools online, right? Like we have to compress it and send it to the receiver. The main problem with compression is that it will reduce the quality actually. Then talking about the application layer. Application layer is all about the user interface that we see on the screen. Like when you are using your Gmail, the functionalities that are visible on the screen, like on your monitor, those things are the application layer concepts. In application layer usually enables the user, whether human or software, just to access the network. The services provided by the application layer are network virtual terminal. For this means it allows the user to log in to a remote host. Then file transfer, you can upload or download files from a remote system, or to upload to the remote system actually. Then mail service, it provides the basis for email forwarding and storage. Finally, the directory services, for example, it provides access to the distributed database, and you can access the data, like the global information about various objects and services. This is all about the OSI model. Next we will see about the TCP IP model. This is more or less similar to the TCP OSI model. Only difference is that instead of 7 layers, they just have 4 layers. So in OSI model, these application presentation and session layer, it is merged as a single application layer, and the transport layer in OSI is the same as the transport layer in TCP. A network layer in OSI is the same as a network layer in TCP. And the physical and data link layer in OSI, it is merged as a single network interface layer in the TCP IP model. Yeah, TCP IP is a result of a protocol research and development which was conducted on the experimented packet switch network, which is called the ARPANET. This project was sponsored by the US Department of Defense. The application layer, what it does is, it just provides the user interface, just how we saw in the OSI layer. So the protocols which are in this application layer are HTTP, HTTPS, a secure shell, then network transfer protocol. HTTP is mainly hypertext transfer protocol. So every web page will be encoded using this HTTP. HTTP is access for the extra security. Application layer enables the user, whether it is a person or a software, to access the network, and the protocols that are used by the application layer are HTTP, HTTPS, Secure Shell, NTP, etc. HTTP is hypertext transfer protocol. So every web page is using this protocol HTTP, and HTTPS means security. So secure web page. This means secure web page. So the data which you upload to HTTPS website means your data is safe and it can't be tampered. So mainly banking pages and online shopping pages will be encoded by this HTTPS scheme. Next, talking about the transport layer. End-to-end transmission takes place with the help of this transport layer, same as the OSI model, and we have two communication protocols, TCP and UDP. TCP is transmission control protocol, which is reliable, and it is completely connection oriented, which means dedicated connection will be set up just like a phone call between two nodes. They are communicating. After the handshake, it will send the data, receiver will acknowledge data, acknowledgement, then finally request to terminate the session, and session closed. But UDP, user datagram protocol, is unreliable, which is connectionless. So TCP, it is a connection oriented, it ensures the end-to-end data delivery and it can handle flow control. But UDP is a connectionless protocol which is unreliable. In TCP we have a sequence number in order to in order to merge the data after receiving, but UDP don't have the sequencing or flow control. Next, talking about the internet protocol layer, which is this layer is used in order to provide the routing function across multiple networks. This protocol is implemented in the end system and in routers also. The primary function of a router is to relay data from one network to the other network, and the protocols we use here are internet protocol, ICMP, ARP. We can discuss about this later. And then finally we have the link layer or the host to network layer, which deals with the features of both the physical layer as well as data link layer. Physical layer, what it does is physical transmission of data, converting the digital data bit stream to signal and then passing it through the air or the physical medium. Then data link layer, what it does is hardware addressing, like we need to know the source MAC address and destination MAC address in order to transfer data. The data link layer provides data transport across a physical link. It includes logical link control layer, sublayer, and the medium access control sublayer. The physical layer specifies the electrical, mechanical, procedural and functional characteristics of the physical link between the end systems. So, and some applications of networks may be in marketing field, cable TV, cellular, telephone, etc. In all these areas, networking can be used. So, in this video, we saw about what is a network architecture. Why do we need architecture? Like it is just a blueprint, and we saw about the two architectures like OSI architecture and TCP. This has 7 layers, and this has 4 layers. In the next video, we will be discussing the other concepts of layering. Thank you.